So what about fixed costs? Do they actually, can you still get this persistent misallocation that we observe in the data? And the answer is both yes and no. So intensive margin misallocation, no. So there is no, it disappears in the long run for the exact same reason we said before, but the extensive margin misallocation persists. So the guys who weren't in business initially, they're actually going to stay out of business. So this is kind of interesting because what you are going to be able to get is big GDP and TFP differences because of the wrong guys being in business. So you're kind of halfway there, but the one thing you are not going to get is big intensive margin misallocation, which is something we see in the data. This is like the first whole 2 slides that I showed you was all this evidence that margin products aren't equalized. So you're still going to get this fact that marginal products are in fact equalized. So,
but you can have the same thing with fixed adjustment costs.
Sorry.
So it's like I already have a plant, but I still have to pay another fixed cost to like expand the plant by 100%. So that's
So that's a fixed cost too.
That'd be like an extensive, but on the intensive side.
No, so we would also call that extensive margin misallocation. Like the marginal products would still be equalized, but one is just like, so you have like a non-convexity, right?
Yeah.
And one would be like on the lower one, and one would be on the upper one. We'd still call that extensive margin misallocation. But and that's going to persist, but the marginal products will be equalized in the long run, so there's no intensive margin. So as I just said, so there's still this difference in the model and the data. So in the data, you see a lot of intensive margin misallocation, but the model you still don't. So there's this like kind of inconsistency. Why does this misallocation persist? So like the next possible step is to introduce shocks into the model. So this is a paper I have with a guy called Takubura. And the idea is that what about if you, so remember the Z ability before it was fixed? So and the result was just that because the Z is fixed, you know that you're going to be very able or very stupid forever, so you're going to adjust your wealth to whatever your ability is. So now, what do we think? Can we maybe break this result if we introduce ability shocks? So these guys are kind of like saving up to where their capital should be, but then you like hit them with a shock, and you try to get them away. So the simplest way of doing this is above you assume that people live forever, which is kind of obviously a bad assumption, and that they have fixed ability. And here we assume that they have finite lifetimes, and that the ability is tied to individuals, and that they might then they might die at some point, and they get a child who has a different ability. So this idea has been like called dynastic management issues, and there's this paper by Caselli and Gennarioli. And what they basically say is that you see a lot of family firms in developing countries, and the ownership usually stays within the family, and that at first, so their theory why some developing countries do so badly is that at first the companies are managed by the very able manager, but then the manager dies at some point, and he gets this really stupid child, and this really stupid child takes over the company and then just like runs it into the ground. So this is called dynastic management, and it's one theory. So we can easily incorporate that in here with almost the same model, no fixed cost for simplicity. So I'll just be like very quick. So you have a continuum of individuals. They have what is the same as before. Now we just assume 2 ability types. They're a fraction, like proportion mu1 and mu2 of each in the population, and they die at some constant hazard rate. Is the easiest way to model like the finite lifetimes. So the expected lifetime you can show is 1 over the constant hazard rate, and then the idea is exactly what I said before. So they accumulate or disaccumulate some wealth during their lifetime. At some point they die unexpectedly, and they just leave their wealth to their children. But the children might, like, they get a new ability job. So the father might be very very able, but the child will like be really stupid, or the other way around.
Wait, so if this is true, you still see the stock markets and their unexpected deaths of family founders.
Yeah, exactly.
Has anyone done that?
Yeah, no, yeah, exactly what you were just saying. There's a study, I think in some Latin American. No, I have to look it up. Yeah, I read that like half a year ago or something. Yeah, they look at the stock market valuation of they don't look at deaths. They look at what happens if ownership changes within the family. So if the father passes on the sorry.
That should be sort of expected.
Yeah, but they have some sort of instrumental variable. But the idea is that the stock market value actually does drop. So there is this idea that the stock market does have this perception that probably the child is going to be a dummy and you don't want anything like that. Right.
Versus unknown, and there's more risk.
Well, but if it were like, if he were expected to have the same ability on average and there were more risk, then that shouldn't make a difference. It must be something that they expected to be lower, otherwise it wouldn't drop. But so the model is kind of the same. We make it in continuous time. I'm actually gonna skip the technicalities. So I mean, this is exactly the same setup as before. You just have like some present discounted value of utility and some budget constraint. Now you take into account the probability of that. It doesn't really matter. So all I really want to get out of this is savings policy functions. So AT is wealth, and dA of t by dt is the rate of change of wealth. So this is typically what these savings functions look like. So there's some target wealth level. If you're below the target wealth level, it says that here this is 0. It says that the rate of change of wealth is positive, so you like accumulate towards the target wealth level. If you're below it, you go towards the target wealth level again. So what happens in this model? You have two ability types. So suppose one guy starts off at his target wealth level here, then he dies, and he's the low type, right? So here are the two savings policy functions for the two types. So this is the low type and this is the high type. The low type has a lower target wealth than the high type, which kind of makes sense because the low type is less able, so he should be owning less capital. So the low type is going to die, and he gets a child, which is the high ability type. So for him, the savings policy function is this one right here. So he's going to start accumulating towards his target wealth level. And here, I don't know. So say here, somewhere here, he dies again. Then he gets a child, but the child stays high ability. Then they go in here. But then he dies again. Child is low ability. So there you start moving around in this thing somehow. And basically, we want to solve for the distribution of wealth that is generated by this like churning around, and see how production is affected. So I'm gonna skip how to do that in particular, but what you can basically get is these wealth distributions.